All right, Algebra 2, welcome to your video for Thursday, October 14th. We are getting this game plan, Chapter 3, Part 1. We are getting this started. Hopefully you know a little bit about solving systems. You did see this in Algebra 1 a little, so we're going to do some that I think that you can handle. Obviously, we'll talk about this a bunch when I hopefully come back to you on Tuesday, October 19th. Folks, we got, as you know, those in-house sponsors. Crystal Light, Pure Energy. Noon, Hydration. Energy for a recharge. You know we like that. Cliff Bar, seasonal flavors. We're planting 1 million trees. Looks like more game plans are coming our way. And Laura Bar, also Zevia, the 0-calorie soda. All right. Ginger root beer. Oh, don't forget, they want to be introduced, folks. We have an in-studio classroom here. Yes, we do. Elsie's Plush Toys making an appearance. And starting on Friday, the 15th of October, premium sponsor here, Knee Rover Knee Scooter. Can't wait to be using that. Stuart the Minion is currently keeping that thing occupied and in tip-top shape. Yes, Stuart the Minion, our favorite in-house teaching assistant. All right, here we are. We're going to do pages 1 through 3 and SAT page 42 today in this video. All right, so what we got here is a little graphing. This is page 1 of the very first page. I have tried to graph each one in a different color. The first graph here, y equals 2x minus 1. The y-intercept is a -1. Then I kept going up 2 over 1, up 2 over 1. I can also go down 2, 1 to the left, down 2, 1 to the left. We'll have to do that sometimes. Make a line. You got to make a line that goes through it, okay? Now, I made, on that first graph, make as many dots as possible. On the second graph, you don't have to. We care about where these intersect to solve each system by graphing. It's all about where these two lines intersect. So the second line in blue has a y-intercept of 4. Then I go down 1 and over 2, and ding, 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 I have found their intersection. I don't need to graph anymore. Some students just make a collection of dots and then they start on the other one, just make a collection of dots. If you do that, that's fine. Just make sure to connect everything with lines after you are graphing 2 lines. Make sure you show that you're graphing 2 lines. Anyway, the intersection is 2, 3. If you're ever confused about an intersection, maybe your graph's not too good. Like, oh man, I know it's x equals 2, but what is that? Is that x equals 3? Is that x, or y equals 3, y equals 2? Just plug 2 in for x. 4 minus 1 is 3. -1 plus 4 is 3. So that's my answer. I graph those two and I find out where they intersect. My intersection is 2, 3. All right, let's take a look at number 2 here again in black. This one, y-intercept of -3. I'm going to go up 4 over 5, up 4 over 5. I'm going to go down 4, 5 to the left. Makes that line. And this next one is a y-intercept of 6 and a slope of -1. That means down 1 over 1, 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 until ding, ding, ding. They intersect right there. Where do they intersect? When x is 5 and y is 1. 5, 1. All right, solving by graphing is gonna be pretty easy, unless I make a boo-boo, which I did on page 17. We'll talk about that later. Y equals a -2x plus 3. Slope's -2. You have a y-intercept of 3. You're going to go down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right. You can also go up 2, 1 to the left, up 2, 1 to the left. Next one, y-intercept is a -6, and your slope is 1. So from -6, rise 1, 1 to the right, up 1 over 1, up 1 over 1. Ding, ding, ding. They intersect at 3, -3. That's your answer, 3, -3. Take a look at number 4. You have a y-intercept of 1. You go down 3 over 4, down 3 over 4. You can go up 3, 4 to the left, up 3, 4 to the left. Then I have a y-intercept of -7. I go up 1, 4 to the right, up 1, 4 to the right. Ding, ding, ding. They intersect there at 8, -5. Plug in 8 for x, you get -5 for y there and there. That is page 1. All right, moving on here to page 2. We're not going to do a ton of graphing. All right, solve by substitution. What does that mean? Well, first off, folks, this is the easiest substitution one we have. We have y equals and y equals. Again, from the last one, we're not going to graph these. Goodness, this is a y-intercept of 16. This is a slope of 5. Where are they going to intersect? They will intersect on a 10 by 10 coordinate plane, though, but I don't want to graph this. No, no, no. So I know from the previous one, they intersect at exactly the same y value. So if y equals this and y equals this, y is clearly equal to itself, so that means 5x minus 2 must be equal to -4x plus 16. It's substitution because I'm plugging that in for y, because that equals y. Or I'm plugging this in for y, because that's also equal to y. Anyway, I set 5x minus 2 equal to -4x plus 16. All right, we should be good at solving equations. We're in chapter 3 now, so the arrows means I'm moving this over. I'm adding 4x to both sides. I'm adding 2 to both sides. I get x is 2. So I'm going to plug 2 in for x. 5 times 2 minus 2 is 8. 2, 8. So show that work there. All right, that is kind of the only one of its kind there. Let's do 7 first. I want to use substitution when I have a single variable all by itself. So x plus 3y equals 10, that's standard form. I don't have any variable by itself. But here, I know what x is. Now, it's not a number, it's an expression here, 2y minus 15. But I can substitute, hence solving by substitution, I can substitute 2y minus 15 in for x in that first equation. So I'm going to rewrite the first equation, but instead of writing x, I'm going to write what x is. X is 2y minus 15. So x, which is 2y minus 15, plus 3y is equal to 10. And I can solve this because I only have one variable. I get y equals 5. And if I know what x is double y minus 15. Well, y is 5. So x is 10 minus 15, -5. -5, comma 5. Write it as an ordered pair. So I've got a few like that. Let's go back to 6 here. Y equals 4 minus x. I know what y is. And the second one, written in standard form. I could divide everything by 2 here. A book might show you doing that. But I laid off of that. 6x plus 2y is 12. Well, I know what y is. Y is 4 minus x. So in this equation here, instead of writing y, I'm going to write what y is. I'm going to substitute 4 minus x in for y. So 6x plus 2y, which is 4 minus x, is equal to 12. Do low distribution. All right, combine like terms. 4x plus 8 is 12. Subtract 8 from both sides. I get x is 1. We'll go back here. This first equation says y is 4 minus x. So y is 4 minus 1. Y is 3. My ordered pair, my intersection is 1, 3. All right, take a look at 8. I know what x is. Again, we're going to use substitution when we have a variable all by itself. X is 3 minus 2y. In the second equation, I have 4x minus 5y is equal to a -40. So if I know what x is, x is 3 minus 2y. I'm going to plug that in for x right there. 4 times what x is, 3 minus 2y, minus 5y is equal to -40. Now I have an equation only in a single variable, which is good. All right, again, I know what x is. X is 3 minus 2y, so I'm going to plug that expression in for x right there. So now I can solve an equation for y. Distribute, again, we got to be good at solving equations. Combine like terms. I'm going to subtract 12 from both sides. I'm going to divide by -13. Y is 4. We're going to get pleasant answers. There's only a few that it's not so pleasant. You know, if you get something like a half, that's just fine. But if you get, 23 over 7 or -18 over 11, we made a boo-boo. Okay. X is equal to 3 minus twice y. We'll plug 4 in for y. X is a negative 5. All right, let's do number 10 real quick. I know what y is. It's 2x plus 3. So I'm going to plug 2x plus 3 in for y in the second equation. So 5x minus 4 times what I'm plugging in for y. What am I plugging in for y? 2x plus 3. I'm going to distribute negative 8x minus 12. 5x minus 8x is a negative 3x. Add 12 to both sides. Divide by negative 3. X is negative 6. I'm going to plug negative 6 in for x right there. I know what y is. It's double x plus 3. Y is a negative 9 then. Again, we'll practice these a bunch when I see you again. So number 9 is a technique that eventually we're probably going to use something called elimination, because you don't have a single variable all by itself. Well, since this page says solve by substitution, we will. You can either move that y over and that 4 over, or like I did, you can move the y over while moving the 1 over. So I can say that y is equal to 2x minus 1. Just add y to both sides, and I subtract 1 from both sides. So I know what y is. I'm going to take this 2x minus 1, and I'm going to plug it in for y. And that's first equation. So I'm going to say 5x minus what y is, all of what y is. Y is 2x minus 1 is equal to 4. So 5x minus 2x is 3x. To subtract a negative 1 is to add 1. I get x is 1. Then using this right here, y is 2x minus 1. I'm going to plug 1 in for x. Y is also 1. All right. And then let's go to page 3. Solve by elimination methods. Elimination. A little different than substitution. So, man, I don't... Look at 5x plus 3y is equal to 30. 3x plus 3y is equal to 18. I don't have a single x or y anywhere. Don't want to use substitution. Now, I notice I have a 3y and a 3y. Is there a way, again, because I want a single variable all by itself. I want an equation with only x or only y. So I asked myself, is there a way for this 3y and that 3y to be made into 0? Is there a way for 3 and 3, when I put them together, to give me 0? And there is. If I subtract 3y minus 3y eliminates the y. So if I take equation 1 and I subtract equation 2, my y's are going bye-bye. And I subtract because both of these y's have the same sign. A positive 3 and a positive 3 become 0 only through subtraction. So that's what same sign subtraction means. Think about the alliteration. On the variable you're trying to eliminate, we're trying to eliminate y's because they match up perfectly. They both have the same sign. They're both positive. In order to eliminate them, I need to subtract. Even if they were both negative 3's. Negative 3 minus a negative 3 is 0. Negative 3 plus negative 3 is a negative 6. That doesn't solve your problem. So I take equation 1, I subtract equation 2, and I just line them up. 5x minus 3x is 2x. The y's cancel because 3y minus 3y is 0. And, oh man, I made a boo-boo. 30 minus 18 is not 18. It's 12. So x is not 9, it's 6, which means y is not going to be a negative 3. In fact, y is going to be 0. So x is 6. So then you just pick an equation. Do you want to use equation 1 or equation 2? So plug 6 in for x in one of the equations. I chose equation 2, which I need to fix here. So 3 times x plus 3y is 18. That means 18 plus 3y is 18. If I subtract 18 from both sides, I get 0. 3y equals 0. Well, y is simply 0. So my answer is 6, 0. All right, elimination. So let's do one more where we're going to subtract, where it's obvious where we want to subtract, and that's number 13 here. We'll kind of skip around, take a look at 13. I have equation 1, I have equation 2. I have x plus 3y is 12. I have x minus 4y is 26. Now, what we could have done is we could move this over. X equals 4y plus 26. I can plug 4y plus 26 in for x there. That's fine. But, man, you got x and x. A single x and a single x. I can eliminate those if I subtract. 1 and 1 becomes 0 through subtraction. Positive x, that's the same sign. You're going to subtract. All right, so x minus x is no x's. 3 minus a negative 4. Be careful. 3 minus a negative 4 is 3 plus 4. That's how I get 7y. 12 minus 26 is a negative 14. Negative 14 divided by 7 is a negative 2. So I'm going to take negative 2. I can plug it in for y there or there. I chose the top equation. Number 1. Organize yourself pretty well. So I'm going to say x plus 3y equals 12. Add 6 to both sides. 18 comma negative 2. All right, so kind of one more of those. Then we're going to have to multiply. So I showed you 2 different ways here on number 12. We have done nothing but subtraction on the first 2. So if you like that, you notice, hey, x and x, both positive. I can get rid of the x's by subtracting, right? I can do x minus, I can do equation 1 minus equation 2. The x's cancel. I have a single y minus a negative y. So I'm adding. 1 minus a negative 1 is 2. 12 minus 2 is 10. I get y equals 5. I can use that top equation. X plus y, or x plus 5 equals 12. So x is 7. Got my answer. Or, because if we're being honest with ourselves, we probably like addition better. I have a positive 1 and I have a negative 1. How does a positive 1 and a negative 1, how do they become 0? Well, if you just add them up, you get 0. They cancel. 1 plus a negative 1 is 0. 1 minus a negative 1 is 2. So you want to eliminate a variable. So if you have opposite signs on the variables you're trying to eliminate, if they're opposites, you can add them together. Opposites, when you add them together, get 0. All right, so opposite sign addition. So if I add these 2 equations together, y plus a negative y, the y's cancel. X plus x is 2x, and that equals 12 plus 2, 14. X is 7. So then I can plug 7 in for x, maybe right there. 7 plus y is equal to 12. Y is 5. Again, so that's 2 different ways to do that. Now, I'm going to tend to the side of adding. So any video I make, any review I do, I'm going to add if I can. All right, so you shall see that on 14. All right, so on 14, you'll see this more often. They're not going to match up exactly, but is there a way in equation 1 and 2, look at the variables. So the x's are opposite signs and the y's are opposite signs. If I'm looking, if I double equation 2, I can get 3x to be 6x, and then they'll be exactly opposite. So if I take equation 2 and I double it, I'm going to get 6x plus 12y equals 72. Equation 1 is, just rewrite it. I'm doubling everything in equation 2. Why am I doing that? Because the x's are exact opposites. So when I add equation 1 and 2 together, the x's cancel. Negative 8y plus 12y is 4y. Negative 44 plus 72. Again, 72, not 36. You're doubling that. That's a common error. Students don't double everything. 4y is equal to 28. Y is a nice, pleasant 7. So I'm going to go back, either the new equation 2, the old equation 2, or the original equation 1. I chose the original 2, and I'm going to plug a 7 in for y. 3x plus 6 times y is 36. Do that arithmetic. X is a negative 2. Negative 2 comma 7. All right, let's take a look at 15. So I'm looking at 15 as 6x and 4x. There's not a way, unless I want to multiply by 1.5, which wouldn't be terrible here, to make 4 into 6. But man, there is a way to get 5 and 10 to match up. If I double this first equation, multiply everything in the first equation by 2, which is what I did here, my y's will match up perfectly. 10 and 10. I don't want to add the equations together because 10 plus 10 will give me 20y. I want to subtract because I want my y's bye-bye. All right, so I'm going to subtract both the equations because 10 minus 10 is 0. 12x minus 4x is 8x. Negative 54 minus a negative 46 is a negative 8. Be very careful when you subtract negatives, or when you subtract in general. X is equal to a negative 1. So I'm going to use and this is where I made a slight boo-boo here. I'm going to use the original equation 1. I'm going to plug -1 in for x. Again, you can plug -1 in for x there. It doesn't matter. So 6 times the -1 plus 5y is a -27. And I get y is a -4.2. -1, -4.2. That's a oopsie. Oh, well. And lastly, 16 is kind of the most complicated that this will get. Now, you might have learned in Algebra 1 to like multiply an equation by a negative so they match up to be opposites. You know, that's fine, but I'm never going to multiply by a negative, all right? Because we can subtract at this level. That's no big deal. So take a look at 16. There is no way to get 5 to match up with 8 by multiplying by a single number. There's actually no way to get, unless you want to multiply by 1.5, which you don't, to get 2 to be and 3 to match up by simple multiplication. So I want to eliminate the y's because I have opposite signs, and opposite signs mean I can add 2 equations, and I like to add instead of subtract. So I can make 3 and 2 match up by taking that 3 and multiplying it by 2. Taking this 2 and multiplying it by 3. Again, I'm not going to multiply by -3. I'm going to multiply by a +3. So if I double the first equation, that's what I get. If I triple the bottom equation, that's what I get. -6y, +6y. Add them together, they're opposites. 16 plus 15 is 31x. -22 plus -9 is a -31. X is a -1. All right, I'm going to take that -1. I'm going to plug it into one of these originals probably. That second equation where y, I'm solving for y now, so I'm going to work with a +2y. Plug -1 in for x. And I get y is +1. Okay, we should be able to handle that arithmetic. -1, +1 is my answer. All right, and last thing we're going to do here for your Thursday notes is, this is SAT question. We've definitely erased the legal stuff there. Page 42. Which of the following is the graph of that equation? Okay, so there's not much work to be shown here. Write that the y-intercept is a -5 from that equation, and the slope is a 2. It's a +2, so it can't be this one. That's going down. The y-intercept is a -5, so it can't be that because that's positive, right? And the slope is 2/1. So there's -5, up 2/1, up 2/1, up 2/1. That one is very easy. It's in the non-calculator part, but we don't need a calculator for that one. So that is D. So write everything that I have right there, and we will be good to go. All right, folks, that is your Thursday notes. This is Yak Math Videos signing out.